Hello and welcome back to the channel, and today is our follow-up video of the air compressor, the work I did on that, where I replaced the original distributor that was a little bit worn point system with a new electronic distributor from 𝐃𝐨𝐬𝐫𝐞, and very happy with the outcome of that. So there were a lot of questions about why I did that versus just filing the points or putting new points and condenser in it or whatever. This thing sits so much that every time I go to use it, I fight with the points. I have to clean them, file them. I want something that's reliable. I just go out, fire it up, and go to work. That's the whole point of this machine. You know, I've traveled across, 5-6 hours away to do air testing on equipment, and get there, and now I got to spend half an hour getting the compressor running, and I just don't like that, and that's getting it running the day before. They corrode overnight, the weather's just right, whatever. It's just not something I want to deal with anymore. So that was the whole reason for putting this electronic distributor in here. For the money, 260 bucks or so for everything, I think it was well worth the money. Another common question or comment I got was on the air tank. I said this thing was built in the 60s. This tank is not from the 60s. This is not original to this compressor. This compressor unit itself was this with a little 6-gallon air tank mounted to the back end of it. That was it. I added the 120-gallon tank later on, which is an ASME code stamped tank. It has been inspected. It is safe. And a lot of people were commenting about all the moisture in my air. That's not all moisture. That's oil. Because this thing isn't running, firing on them 2 cylinders, there is some oil carryover going into the air. There's a lot of oil that condenses in this tank. Another problem that there is with this thing is you're compressing air, you're making heat. Well, with a regular air compressor, that air is coming in cool, it's going into a cylinder, it's compressing and making heat. This air is coming into a hot cylinder, 180, 185 degrees, whatever engine temp is, compressing it and putting it out. It's coming out really hot. And I don't have an air after cooler on here yet. I've been looking for a small hydraulic oil cooler that I can mount out here in front of the radiator. The fan is pulling in, so it would cool that air. But I need a 1-inch inlet, 1-inch outlet hydraulic oil cooler is what I want to use, because a hydraulic cooler is rated for a lot higher pressure than most air coolers. So that's what I want, is a good hydraulic oil cooler. That'll work good. And then I can come into the oil cooler, out of the oil cooler to my tank, and then all that liquid will condense in that amount of time and settle right out to the bottom of the tank, which the tank gets drained multiple times throughout the day as it is now when we're using it. I do also have external filters that we use for different things. So if we're doing something, important, I do filter the air. But when you're making that much heat and running it like that, it's gonna make moisture. You're pulling humidity out of the air, you're compressing it, heating it, and it's going to that tank gets so hot, it just does not condense and drop out. Like your compressor at home, your small commercial compressors, all of them, that air has time to cool and drop, whereas this, you're running such a volume, they don't cool. It just does not. Even the big screw compressors, they run through an oil cooler. The air and oil go together through an oil cooler, and then it condenses and drops out. So that's the biggest downfall with this compressor. Other than that, I absolutely love the thing. So there were some questions a couple people asked about what is the output of it. So I've got my safety valve set at 150 psi. My cutout is 135. I didn't see much point to go beyond that. I know guys have run these up to 150, 160 for the cutout. And when I said this is a general supply 260, meaning 2 cylinders, 60 CFM, so 60 cubic feet a minute, and I think they're rated at 90 psi at 60 CFM. So it's a pretty good output compressor, and I verified that by calculating the volume of the tank and then measuring runtime and all that, and the calculation came out right around 62 and a half, somewhere in there. So it is very close on the 60 CFM. Now, to those of you doubting me that this is an ASME code stamp tank, here is the data tag. And I know it's hard to see, but there is the U stamp right there with the clover leaf. The date on here is 1978, but this was a new old stock tank that I had picked up really cheap. It is in very good condition. The ultrasound readings on it are at 100% thickness. There is no deterioration whatsoever in this tank. It had never been used. So, and actually, if it had been used, it was probably used as a receiver tank because nothing was ever mounted up here. There's no signs of use whatsoever. So it is an ASME code stamp tank. Ultrasound it before I put it together. I did a hydro on it. I do have a hydro pump and do hydros on a regular basis with either my steam engine or I also have done hydro and hammer on historic rail equipment, locomotive air tanks. So tanks that are not drilled on the railroad get hydroed and hammered. All right, we'll come in here now. I'm gonna just kind of go over this. We did have that stud come out. Somebody asked about putting thread sealant on it, and I did not, just because I wanted to get it sealed back up quick, but it does not leak. It's a very tight stud in there, so it's kind of weird. I added a tank heater on here at one point because I was doing air brake testing at 30 below zero, and I had a hard time getting this thing started after a 5-hour drive. So we ran to town and bought the parts and put it together, plugged it in for half an hour and fired it right up. So that was a great accessory to add. Here's the original data tag if anybody's interested. And one other person had commented on this, and I want to mention this about timing. Brian Block was actually the one who mentioned it about timing using vacuum. And so I gave it a lot of thought because I used to time a lot of stuff by vacuum. And I thought, you know what, it's not going to work on this thing because it never drops to idle. So that butterfly on the throttle is never closed. And I verified that. I took out this plug and put a fitting in there, and absolutely no vacuum because, well, it was like 8 pounds or inches of mercury because the throttle's open. It's drawing air. So as long as the throttle's open, it's not going to make huge vacuum at idle. It just doesn't idle. And then wide open, it's not going to make vacuum either. And one other question we had was about the head and the cylinder, how they blank that all off. Well, you can't really see up in there, but what they did in this head is they blanked off the valves. So the intake and exhaust valve are no more. And then you got your unloader valves up top, and then a reed valve basically that comes out to this pipe here, and that's going to my tank. So there's no gas going into that cylinder whatsoever. So I hope that answered all the questions. There were a lot of good questions, but the people freaked out about the air tank and not being safe. You gotta know what you're doing with pressure vessels. That's all there is to it. I'm one of the most important things to me when it comes to pressure vessels is safety, and I take it very seriously because I own many pressure vessels, including a boiler, and every pressure vessel is a ticking time bomb. And I have worked with the CFR, the ASME, the National Board, all of their testing requirements. I have met all of them on pressure vessels, and I take it very seriously. Pressure vessels, yes, absolutely dangerous to an idiot. So this one is not an issue. Like I said, most of what you're seeing come out of that drain is oil vapor and some water from condensation. But it's also drained multiple times throughout the day. Usually when I park this, I park it on a bit of an angle, so the drain valve is more at the bottom, and drain it out that way. I usually run pressure through it and blow it down. I'm very careful about it. It gets an ultrasound on the bottom every couple of years. It's been hydroed, I think, since I put this together 10 years ago. It's been hydroed every 3 years, I think I've done it. So it's very important that these things are safe to me, especially this thing, 120 gallons. If that thing blew up, that would be pretty devastating. So, like I said, I hope that answered everybody's questions. And Saturday's video, or for channel members, Friday's video, we got invited out to the Squatch 253's property over there in northern Minnesota, and we headed over there. My friend Pete Alexander and I drove over for a plow day, and they were plowing with caterpillars. Biggest thing I wanted to go over for, well, not second biggest thing, was the rock crusher, to see the rock crusher in person, the scale of it, and see what other damages there were to it. He had talked about a couple other things that we might be addressing. So as far as the rock crusher goes, we'll be getting on that here in a little while. We've got a few other projects first, but the first thing we're going to do with that rock crusher, based on everybody's recommendations, was we're going to mag particle that shaft. We're going to look for cracks. We got to verify that that thing is not cracked anywhere or broken. We want to make sure this thing is safe. It is a major project, and we don't want anything failing on it. So if there is a problem somewhere, we'll have to approach it at a different angle. So that's the next step, is to mag particle that. I got a honeybee just landed on my finger. They are out in full force today, just looking for food, getting ready for winter. So with that, stay tuned, check out all the stuff coming and all the stuff in the past. A lot of great content. And until next time, get out in your shop and get it done right the first time.